To find vertical asymptotes, remember that to find your vertical asymptotes exist where the denominator equals 0 because we can't divide by 0. So to find where those asymptotes are, we set the denominator equal to 0 and solve. Sometimes it's super obvious. So if you have a function that's like 2 divided by x minus 3, what x value would make this denominator equal 0? Positive 3. So sometimes you can look at the denominator and immediately you know what the asymptote is going to be. Sometimes, like with number 5, it's not super obvious, and you may have to take that denominator, 2x plus 5, and set it equal to 0 and solve that equation. What would you do first to solve that equation? Subtract 5. That would give us 2x equals negative 5. And then divide by 2, giving us x equals negative 5 halves. The asymptote would be at negative 5 halves. Okay. So take a look at number 6. What do you think about the asymptote or asymptotes in number 6? If we set this denominator equal to 0, if the first set of parentheses equaled 0, it would make the denominator equal to 0. If the second set of parentheses was 0, it would make the whole thing equal to 0. So when would this first set of parentheses be 0? When x equals negative 6. And how about the other one? X equals positive 7. Let's look at this graph because it's kind of fun. Bam. And bam. There are 2 vertical asymptotes on this graph and 1 horizontal asymptote. So if you have multiple factors like that in the denominator, it will create multiple asymptotes, which is kind of cool. All right. Quick little review, and there is an error here, so you need to scratch that thing out because it's wrong. When you have a function that looks like this, with an x on the top and an x on the bottom, you find the horizontal asymptote by taking the coefficients of the x's. So your horizontal asymptote would be y equals a divided by c. Whatever's in front of the x on the top divided by whatever's in front of the x on the bottom. Okay, so number 9, first I want you to find the vertical asymptote like we did in 5 and 6 by setting the denominator equal to 0. Then I would like you to find the horizontal asymptote by thinking about the coefficients of the x's. So take a moment, find the asymptotes. Okay, the vertical asymptote, 5x minus 1 equals 0. You'd add 1 to both sides. Divide both sides by 5. The vertical asymptote will be x equals 1/5. For the horizontal asymptote, you are looking at the coefficients of the x. So that would be 3 divided by 5. Y equals 3/5. Okay, I want you to try number 10 on your own. Find the horizontal asymptote and the vertical asymptote. Set the denominator equal to 0, and if you need to, you can absolutely write this out. X plus 1 equals 0, subtract 1 on both sides, x equals negative 1. For the horizontal asymptote, you take the the coefficients of the x, 4 divided by 1 to get 4. We are going to do number 14 together because I think it is one of the more difficult of these, and we are going to talk about number 13 briefly before the end of the video. So number 14, first thing we need to do is figure out the vertical asymptote and the horizontal asymptote. For the vertical asymptote, you put the denominator equal to 0 and solve that equation. We would subtract 3 on both sides and then divide both sides by 2. Normally I would say leave it as a fraction, but in this case we kind of need the decimals so we know where to put this on the graph. What is negative 3 divided by 2? Negative 1.5. So our vertical asymptote is x equals negative 1.5. On your graph, that means the vertical asymptote would be here between negative 1 and negative 2. This problem is a little bit of a trick for the horizontal asymptote. If you're thinking right now that the horizontal asymptote is positive 3 over 2, that's not right. Remember, the horizontal asymptote is the coefficients of the x's. What's the coefficient of the x on the top? There isn't one. It's like there's a 0x up here. So 0 divided by 2 is 0. The horizontal asymptote will be 0. Now, if there was something added or subtracted right here, that would change that horizontal asymptote. But there isn't, so the horizontal asymptote is at 0. And if you need to stick this in your graphing calculator to verify that, you absolutely can. In fact, our next step is put this in the graphing calculator. When you enter this in your graphing calculator, you're going to do 3 divided by parentheses 2x plus 3. If you were entering number 13 into the graphing calculator, you would want to put parentheses around the entire numerator and the entire denominator. So y equals 3 divided by parentheses 2x plus 3. If we want to graph it to verify our asymptotes, we can, or we can go straight to the table. On the table, the challenging thing is, which points do you use? You want to focus on the x values that are around the vertical asymptote. So we know we can't use negative 1.5, but we can use 0, negative 1, negative 2, and negative 3. So I'm going to do negative 3, negative 2, negative 1, and 0. It's kind of like my asymptote is that number in the middle. That negative 1.5 would be right there in the middle of all of those. So 2 points to the left of the vertical asymptote and 2 points to the right of the vertical asymptote. So in this table, negative 3, negative 1, negative 2, negative 3, negative 1, 3, 0, 1. And I'll plot those 4 points. Okay, now I don't know about you, but are those 2 points really enough on either side to get a good view of the hyperbola? For some of you, yes, but for others, since we didn't really have to do any work to get these points, you can grab a couple more. So I'm going to grab negative 4, negative 0.6, negative 5, negative 0.4, 1.6, and 2.4. Just adding those 2 more points makes this curve look a lot more, I don't know, visible. Whoa, definitely not straight like that. And if you want to go back to the graph and look at the graph as you're connecting your points, that is fine. Underneath this table, it says domain. What should it also say under there? Range, it got chopped off in that text box apparently. Does anybody remember how to find the domain for hyperbolas? X can't equal the vertical asymptote negative 1.5, and the range y can't equal the horizontal asymptote 0. These asymptotes tell you where the graph can't be. So for the domain and range, you're just telling us where the graph can't be. Really quickly, over here on number 13, the vertical asymptote would be x equals positive 4, because 4 minus 4 would make the denominator equal 0. The horizontal asymptote, you're looking at the coefficients of the x's, and this time there are x's on the top and the bottom. So 2 divided by 1 is 2. There would be a horizontal asymptote at y equals 2. So that one's a little bit nicer because it gives you whole numbers and you can see both of them easily. Number 14, it's a little bit more obscure.